This is R.D. Sharma solution, class 12, chapter 10, differentiability. Exercise 10.2. If f is defined by fx is equal to x square, find f dash 2. So that means f dash means differentiation, derivative. So wherever this x will be after differentiation, we'll put 2. Direct differentiation is 2x. That is d by dx of x square is 2x. But that is supposed to be learned in the chapter of differentiation. We are discussing the differentiability right now. So we'll do it by the first principle. And we already know that because it is a polynomial, this polynomial function is everywhere differentiable. So fx will be differentiable at x equals 2, right? So let us check it and find out the value as well. So what do? We write this f dash x is 2 here. So at 2 we have to check. So when we were discussing how this first principle came, what we used to do, fx minus fc by x minus c, we used to take the left hand limit, that is the left hand derivative, and then the right hand derivative, we wanted to show that both value comes same. And that is how we arrive at the final formula or the expression for the first principle. So the differentiability, as I just indicated you, 2 minus h we would put, 2 plus h we would put. This is what we used to do, similar to the continuity theory. So this all has come because of that only, which we have already discussed in a stretch in detail. So I am putting this, I am using the first principle directly. So it will be fx plus h minus fx divided by h. Limit h tends to 0. That is going to be f dash x. Okay. So this basically if you put 2 plus h also the same thing is going to come. That is the right hand limit or left hand limit, same thing is going to come. So now we have this f2 plus h minus f2 by h. In place of x, just change it by 2 plus h. So 2 plus h whole square minus f2, that is 2 square. And denominator I'll just write later. And 2 plus h whole square is a plus b whole square, a square plus b square plus 2ab. Then we have this minus 2 square, which is 4 only. So we can just cancel these two. H square plus 4h, you can take h common from here. So please remember, limit h tends to 0 and h in the denominator is always there. I'm not just writing just because I just don't want to waste the time and keep the effort as low as possible. Because main idea is for you to understand the logic or reasoning. Okay, denominator was already there h, so you can just cancel this h and h, numerator, denominator. And h tends to 0, so this is going to be 0, you get 4. So f dash 2 is what? 4. That's the answer. If f is defined by fx, this is a quadratic equation and a polynomial, of course. And you have to show that f dash 5 is equal to twice of f dash 7 by 2. So this 7 by 2 or 3.5 you can say. So 7 by 2. So what we'll do, we'll just find out the f dash x. And then we'll put first the value 5 and then we will put the value 7 by 2. And then we'll try to see whether it comes twice or not. Okay. So f dash x simply, as I said in the first question also, f dash x is simply fx plus h minus fx divided by h. This is the differential or differentiation or the derivative. So now we'll not put the value right now. We will use the quadratic equation in order to get a solution of this quadratic equation. And then we will put this 5 and 7 by 2 value as and when required. Right? Okay. So this fx plus h, we have x plus h, so just replace it by that, x plus h whole square minus 4 into x plus h and plus 7. This is, always put the first term in the square bracket because it is a bigger expression. We don't want to confuse it with the second one, which is only fx, which is x square minus 4x plus 7. And divided by h is also there, and limit h tends to 0 is also there. So limit h tends to 0 and division by h, I am going to write it later, but for you, you have to write it every time, every step it has to be there. So we'll just open this, a plus b whole square, so x square plus h square plus 2xh and minus 4x minus 4h plus 7, and now change the sign because negative is there, so minus x square plus 4x minus 7. X square you can cancel, you can 4x you can cancel, 7 you can cancel, and what do you get? H square plus 2xh minus 4h. Now you can take h common because h is everywhere. H you take common, h plus 2x minus 4 it will be. Now in the denominator it was already h as I told you, and limit h tends to 0 is also there. So just replace it by limit h tends to 0. Okay, this is all. This I am not just writing, you have to write it at every step. H gets cancelled, apply the limit, wherever h is there, remove that term. 2x minus 4, f dash x is 2x minus 4. Now we will put 5 and then 7 by 2. So f dash 5 will be 2 into, in place of x, replace it by 5, you get 5 to the 10 minus 4, that is 6. Now f dash 7 by 2. So this is going to be 2 into 7 by 2 minus 4, 2 gets cancelled, 7 minus 4 is 3. 3 and 6, 3 to the 6. And this is what is being sought in the question. 6 equals 2 into 3, hence proved. Show that the derivative of the function f given by, so this is the function x equals 2 and x equals 1 and 2, these are equal. The steps will remain same. Same thing you have to do, let me write it again. The first principle, f dash x is given by fx plus h minus fx divided by h. Limit h tends to 0. This and this always will be there. I will not be writing it. The numerator is important because ultimately the whole computation lies in the numerator in first principle, right? There will be certain problem if you just miss a negative sign or some term. So 2x plus h whole cube. So this is 2x plus h whole cube minus 9. In place of x, write x plus h plus 12 into x plus h plus 9 minus. Now you just have to write this fx because it is fx minus fx. So 2x cube minus 9x square plus 12x plus 9. Okay. So just numerator I am taking right now. A plus b whole cube is what? A cube plus b cube plus 3ab a plus b. This is the way I remember. You can also remember, or if you have another way of remembering, you can just open this. 2 is already there. So just open this, x plus h whole cube. So x plus h whole cube is a cube, that is x cube, plus h cube plus 3ab, 3 into x into h, and a plus b, that is x plus h. You can also open this, x cube plus h cube plus 3x square h plus 3 xh square. And since we have 2 also there, so multiply 2 and then write it here, 2x cube plus 2h cube plus 3 to the 6, so 6x square h plus again 6xh square. Now we have 9 here. Let us open this x plus h whole square here first. So x plus h whole square, a plus b whole square will use a square plus b square plus 2ab, and 9 is already there outside, so 9x square plus 9h square, 9 to the 18. Now since negative is there, so you can just change the sign and add it with the numerator. So minus x, 9x square minus 9h square minus 18xh plus 12x plus 12h plus 9 minus, Since you have a negative sign in front of fx, you can just change the sign and write it. Minus 2x cube plus 9x square minus 12x minus 9. Okay. So most of the things are going to be cancelled, as we saw in the previous questions. This good gets cancelled. 9x square also gets cancelled. Minus 12x is also there. Minus 9 is also there. So you have 2h cube plus 6x square h. All of them are having h. So I'll take h common and then I'll keep all the values inside except one h. And in the denominator it was h already. I'm not writing it, but let me show you what terms we get. H square plus 6x square plus 6xh minus 9h minus 18x, and then we have plus 12. Okay, so all are done. Now let us write this denominator h and limit h tends to 0. This gets cancelled. Remove all the term having h. This one also. So what do we get? 6x square minus 18x plus 12. So this is your differentiation. This is your first principle. F dash x it is. Now the question is saying at x equals to 1 and x equals to 2, you are going to get the same value. So let us put it. F1, 6 into 1 square, that is 6 will be minus 18 plus 12. F2 is what? 6 into 2 square. So 6 into 2 square, that is going to be 4, minus 18 into 2, that is going to be 36 plus 12. So 6 plus 12 is 18, 18 minus 18 is 0. 6 plus 4, 6 4 is 24, minus 36 plus 12, 24 plus 12 is 36, 36 minus 36 is 0. Okay? So 0, 0, and they are saying the same thing, so we have also proved it. They both are same. Differentiation is equal. If for the function of phi x, you can also call it as psi it is called as. It has come from Latin or Greek, I don't know, but it is phi. Let me pronounce it as phi x. Okay. So phi x is this is the function. Phi dash 5 is given as 97. Find lambda. Basically, you have to find out the differentiation. And since we are in the chapter of differentiability, we'll use the first principle. Same thing we have to do. Previously it was f, now it is being replaced by phi. Nothing else. So phi dash x will be f, not a f, phi x plus h minus phi x divided by h. What is phi x plus h? Replace x by x plus h, lambda x plus h whole square. H in the denominator, right? So lambda x plus h whole square. Okay. I'm not writing limit h tends to 0 and h in the denominator. I'll just use it when it is required. But you have to write it, okay? So lambda x plus h whole square plus 7 into x plus h minus 4. And then we have minus fx is, phi x is lambda x square minus plus 7x minus 4. Just open it. It will be x plus h whole square, a square plus b square plus 2ab. And this is lambda, so lambda x square plus lambda h square plus 2 into x xh lambda plus 7x plus 7h minus 4 minus lambda x square minus 7x plus 4. Numerator only. Cancel these out, which are same. Lambda x square plus 2 lambda xh plus 7h. Take the h common. Lambda h plus 2 lambda x plus 7. Now you introduce, that is the h was already there. I was just not writing it. So h is in the denominator. Limit h tends to 0 was already there. H gets cancelled. Now replace all the term with h. Remove all the terms with h. So you get 2 lambda x plus 7. This is your differentiation. Now this value, when x is replaced by 5, it is going to get use 97. So phi dash 5 is 2 into lambda, in place of x write 5 plus 7 is equal to 97. This is going to be 10 lambda plus 7. 10 lambda, just write it 10 lambda. 10 lambda plus 7 is equal to 7 I am taking on the right hand side is going to be 90. So lambda is going to be 90 by 10, that is going to be 9. Lambda is 9. This is your answer. Alright. Now this fx is the function find f dash 4. We have already done it, the question just now. So I'll just give you again the idea, that is just replace x by x plus h and subtract it with the original function, divide it by h, take limit h tends to 0, that is the whole concept of first principle. Take h common and then divide it, because division h is there, cancel it out. Wherever h is there, just remove that term. Whatever is remaining is your differential. And finally put in place of x 4. You get 112. Find the derivative of the function f defined by fx equals mx plus c at x equals 0. Now what we do generally is the question is put in front of us and we just try to solve it. But the thing is that this is a line. Y equals mx plus c. You must observe and understand that this is a straight line and the derivative of this line will be m. Why? Because derivative is all about finding the tangent or the slope of the tangent. So y equals mx plus c is a line, c is the y-intercept. If y equals mx, that means it is passing through origin. But y equals mx plus c means you have some c y-intercept. So now finding out the differentiation of this, what do you get? Fx plus h minus fx divided by h. Same thing we are going to do. Limit h tends to 0. The procedure remains the same. This is going to be f dash x. Let us see whether it comes at m or not. So m into x plus h plus c, this is our first term. Write the fx terms which is mx plus c and just open it first, then we'll divide it by h later on. So this is going to be, and limit h tends to 0 is also there. So mx plus mh plus c minus mx minus c, mx gets cancelled, cc gets cancelled, you have mh divided by h, limit h tends to 0 is already there. Now you can cancel h, you will not be able to apply a limit because this is a constant, m is a constant. Now this result is very important. Let us analyze it. See, what is f dash x? What is f dash? What is derivative? It is nothing but the slope of the tangent. The question is, it is itself giving us the equation of the tangent. And you have to find out the derivative of that tangent, and that has to come as the slope. Tan theta dy by dx. Right? So this differentiation should come as m, and that is what we have got. Right? So at x equal to 0, it will remain as m. Why? Because there is no x. Because slope is dy by dx, which is m, which is tan theta, which is, you can say in a nutshell, the idea or the crux or the theory of differentiation. If you understand this concept, everything will be clear to you. X equal to 0 doesn't matter because there is no x here. It is a constant. It will remain as a constant. At any point, x equal to whatever, it doesn't matter. Because it will be m. Because slope doesn't change. This question we'll take in the next discussion. Till then, thank you so much and take care of yourself.